right, let's go through this application exercise. So we're going to use the cheddar data frame from the Fireway package, and we're going to add a variable called time. And so what I'm doing here is I'm assuming that these observations were actually collected over time, which means that when I look at this data set, so let's look at what cheddar looks like now. I've got this new variable time that basically indicates that this first variable was collected first, and the second observation was collected second, the third was collected third, etc. So we're imposing a structure on this data. We're assuming that there's this time component. And so I'm going to fit a linear model to this cheddar data, predicting taste from acidic, SH2S plus lactic. So there's my linear model. And I'm going to plot the residuals from this model against time. So let's create a data frame so we can plot these. Oh, and let's make sure we label our chunks. And so load data is going to be fit model. It's going to be plot residuals. Okay, so let's make a data frame D that contains our residuals and also contains time. Okay, I'm going to load the ggplot2 package. Do ggplot, my data is D. My x-axis, I'm going to have time. And on my y-axis, I'm going to have the residuals. And let's look at those points. And I'm going to add a line here at 0 as well. Let's see. Horizontal line. All right, so this is what it looks like. So over time, these are my residuals. Now, I honestly don't see a very obvious pattern here. It's possible that you could sort of see that maybe they're higher in earlier time and lower in later time, but there's not a super obvious pattern just looking at this. So maybe you could say that the residuals kind of are positive in the earlier times and negative in the later times, but I'm not totally sure just looking at this that I feel certain that there's a time component. And so now I'm going to fit this GLS model, the generalized least squares model, using an AR1 correlation to see if there's evidence of correlation between the errors. And so to do that, first I'm going to load the NLME package. So this is going to be GLS. Now let's do GLS. And we're going to fit the same model here. So it's going to be taste, acidic plus H2S plus lactic, data equals cheddar. But now I'm going to add in the time component. So I'm going to say correlation equals core AR1. Form equals, and I'm going to say it's based on time. All right, so let's see what that looks like. And so my phi estimate here is 0.26. So that's saying that there's potentially this correlation of around 0.2. So not enormous, but not 0 either. Let's check out the confidence interval on that. So that looks like this confidence interval contains 0. So the confidence interval goes from negative 0.169 to 0.6. So that's a pretty wide confidence interval. From this, I would say that I don't feel certain that there's a correlation with time. If someone were to tell me that these data points were really not collected over time, I would not be terribly surprised by that evidence. From what I've seen here, I don't feel certain that we really need to be worried about a time component. So that's how we did this one.